Noble metal. In chemistry, the noble metals are metals that are resistant to corrosion and oxidation in moist air. The short list of chemically noble metals comprises ruthenium, rhodium, palladium, silver, osmium, iridium, platinum, and gold. More inclusive lists include one or more of mercury, rhenium, and copper as noble metals. On the other hand, titanium, niobium, and tantalum are not included as noble metals, although they are very resistant to corrosion. While the noble metals tend to be valuable due to both their rarity in the Earth's crust and their applications in areas like metallurgy, high technology, and ornamentation, the terms noble metal and precious metal are not synonymous. The term noble metal can be traced back to at least the late 14th century and has slightly different meanings in different fields of study and application. Only in atomic physics is there a strict definition, which includes only copper, silver, and gold, because they have completely filled d subshells. For this reason, there are many quite different lists of noble metals. In addition to this term's function as a compound noun, there are circumstances where noble is used as an adjective for the noun metal. A galvanic series is a hierarchy of metals that runs from noble to active, and allows one to predict how materials will interact in the environment used to generate the series. In this sense of the word, graphite is more noble than silver, and the relative nobility of many materials is highly dependent upon context, as for aluminium and stainless steel in conditions of varying pH. Platinum, gold, and mercury can be dissolved in aqua regia, a highly concentrated mixture of hydrochloric acid and nitric acid, but iridium and silver cannot. Palladium and silver are, however, soluble in nitric acid. Ruthenium can be dissolved in aqua regia only when in the presence of oxygen, while rhodium must be in a fine pulverized form. Niobium and tantalum are resistant to all acids, including aqua regia. In physics, the definition of a noble metal is most strict. It requires that the d bands of the electronic structure be filled. From this perspective, only copper, silver, and gold are noble metals, as all d-like bands are filled and do not cross the Fermi level. However, dehybridized bands do cross the Fermi level to a small extent. In the case of platinum, two d bands cross the Fermi level, changing its chemical behavior such that it can function as a catalyst. The difference in reactivity can easily be seen during the preparation of clean metal surfaces in an ultra-high vacuum. Surfaces of physically defined noble metals are easy to clean and keep clean for a long time, while those of platinum or palladium, for example, are covered by carbon monoxide very quickly. Metallic elements, including metalloids. The columns group and period denote its position in the periodic table, hence electronic configuration. The simplified reactions, listed in the next column, can also be read in detail from the Pourbaix diagrams of the considered element in water. Finally, the column potential indicates the electric potential of the element measured against a standard hydrogen electrode. All missing elements in this table are either not metals or have a negative standard potential. Arsenic, antimony, and tellurium are considered to be metalloids and thus cannot be noble metals. Also, chemists and metallurgists consider copper and bismuth to not be noble metals because they easily oxidize due to the reaction O2 plus 2H2O plus 4E4O plus 0.40V, which is possible in moist air. The film of silver is due to its high sensitivity to hydrogen sulfide. Chemically, patina is caused by an attack of oxygen in wet air and by CO2 afterward. On the other hand, rhenium-coated mirrors are said to be very durable, although rhenium and technetium are said to tarnish slowly in moist atmosphere. The super-heavy elements from hassium to livermorium inclusive are expected to be partially very noble metals. Chemical investigations of hassium and copernicium have established that they behave like their lighter homologues, the noble osmium and mercury, and preliminary investigations of nihonium and flerovium have suggested but not definitively established noble behavior.